Computational Humanities Research Group at King's College London, Department of Digital Humanities. Today I'm very pleased to have Michele Ciletti here, who is visiting King's from the University of Foggia. Michele is a master's student in classical philology, languages and history at the University of Foggia, where he also works as research assistant in digital humanities and computational linguistics. His research interests include the application of NLP techniques to classical languages, open data, and digital humanities pedagogy. And today he's going to talk about expanding PREMOVE, an LLM-assisted semantic annotation of Preverbs across historical and modern languages.
Okay. Today I'm presenting a talk that is titled Expanding PREMOVE, an LLM-assisted semantic annotation of preverbs across historical and modern languages. And this is one of the outputs of a transnational mobility grant that I have been awarded by the HU IOSC SE infrastructure in Italy and Clarin. And I've been here at King's College London with Andrea Farina and Barbara McGillivray for a couple of weeks to develop a semantic annotation pipeline for ancient languages based on LLMs and to expand a linguistic research, which I will talk about very shortly, focused on preverbs. And in this talk, I will, firstly talk about preverbs across verbs of motion and perception. Verbs of perception are the main focus of the edition that I have implemented in the PREMOVE resource. And in general about the annotation process, how this resource was expanded and how it was created originally, and why it's important to study preverbs and generally to create linguistic resources based on semantic annotation and diachrony. And then I'll move on to the methodology, and I will talk about several different approaches to perform manual semantic annotation, why it can be important to have reliable and effective systems for semantic annotation, for scalability and accessibility, and creating new open data. And I will talk about the state of the art at the moment and what can LLMs bring to the table and how did we use LLMs to annotate preverb semantics and verb semantics across these two languages. And I focus mainly on WordNet, what it is and what are its peculiarities, its affordances, and even its problems. And I'll also give a series of techniques and practical tips on how to use LLMs efficiently, or at least how they should be used in the best way possible in contexts such as these. And I'll also talk about future perspectives and what this project will bring in the future. Then a second and a third and final part of the talk will be instead focused on an interactive training resource tool for semantic annotation that is based on Google Colab, a platform which I will briefly present. And this was designed with the intention of being accessible and usable even by almost complete novices, so people with no experience in computer science or natural language processing. So it should be possible to use this resource for humanists or historians or linguists who have no training in NLP or CS to perform automated annotations based on LLMs. And since this is the first time that I'm evaluating and trying this resource, parts of the talk will be interactive. There will be some polls so that I can gauge impressions of who is attending this talk and hopefully improve and modify this resource in the future. And actually, I will start right now with the first introductory poll. Feel free to simply scan the QR code or go to the website, which you can see here, the www.menti.com, and enter the code that you can see below, or even just use the QR code. And I'll just briefly switch tabs so that I can yeah, okay, just a moment. Okay.
Also edit out this bit from the recording.
Okay, that's great. So this is just a primary question. What is your primary background? And this can be useful to see which kinds of professionals can use a resource such as this, and also to know what kind of focus to give to the overall presentation, if to focus more on digital humanities perspective or more on the technical side or the linguistic side. I'll just start to show the responses as they come. Yeah. Oh, okay, here. Digital humanities, computational linguistics. Okay, that was mainly what I was supposing, since these are the examples I provided. Okay, well, I'll just leave this here in case anyone else is joining or is just now connecting and wants to add something else. And yeah, okay. So coming back to the presentation. Preverbs are the main focus of this resource. Preverbs are prefixes which are attached to verbal bases, and they are essential in the way that they modify meaning of the verbs they are attached to. So, for example, in Latin, the verb eo, which means to go, can have the meaning of to go out if it has the preverb ex, which means out of, and so it becomes ex eo. But they can also completely change the original meaning of a verb. So, for example, the verb video, which means to see, if it is composed with the preverb in, can become in video, which has, among other meanings, envy or hate. Studying preverbs specifically can help us understand semantic change in the European languages and trace the diachronic shifts of specific words, specific lemmas, in this case verbs, and so how they changed over time and in which ways across which semantic fields. And to do so, a recent quantitative approach is the PREMOVE dataset, which was created by Andrea Farina in 2025 for his PhD project. And it is a large-scale cross-linguistic diachronic dataset of preverbs. It is focused on motion verbs in ancient Greek and Latin. Motion verbs were chosen as one of the main applications of preverbs because as they often entail some kind of movement, motion verbs were the primary case study to focus on. And the resource consists of almost 3,000 manually annotated occurrences across 20 layers of annotation. These annotations are morphologic, but also syntactic and semantic, which is our main focus. And the project has created a Clarion dataset, which follows open data standards and has found a home in the PrevNet interface, which is a web-based resource which contains the entire dataset and the annotations. And it's also been linked to the Linking Latin project very recently, becoming even more open and accessible. And here you can see a QR code in case you want to take a look at the data and maybe use it or download it or simply look at it. So for this specific research stay, we decided to expand the resource and expand its scope mainly. So we decided to integrate perception verbs as identified by class 30.1 by Levin. And as motion verbs are usually more literally meaning, this was an interesting task because perception, on the other hand, does not always entail physical movement when paired with a preverb. So perception verbs have many different abstract meanings, and we thought that this could be interesting to study and quantitatively analyze and integrate in the resource. And we focused on 4 verbal bases for Latin and for Ancient Greek. In Latin, video, audio, prefix compounds in spicio and sensio, while in Ancient Greek, orao, akuo, blepo, and aestanomai. As you can see, the first couple means see, the second one means hear. Then we have look, which is different from seeing, as in it specifically means to which directs towards something rather than simply perceiving it. And then perceive is more general. And we will also integrate Italian verbs in the very near future, this time focusing on motion verbs, because the original guidelines which were developed by Andrea Farina are inherently cross-linguistic. So we wanted to try to apply them to a modern language and go beyond Latin, Ancient Greek, and classical languages, historical languages. And we will include motion verbs, but this is an upcoming output, and today's talk will focus mainly on Latin and Ancient Greek as languages. So the methodology that we used is based on LLMs, on large language models, and I will very soon show why we believe it may be useful and important to integrate LLMs in semantic pipelines, and why they can be efficient and useful, and what are the things that one should be wary about and control very clearly, because LLMs can be black boxes sometimes, and so obfuscate the entire research process if they are not used correctly and ensuring reproducibility. So, automatic annotation. Manual annotation made by experts are often very reliable, but they can be very time-consuming, expensive, and hard to scale. So they may be feasible when a linguistic corpus only has a handful of tokens or lemmas to focus on. But as soon as we arrive to many thousands of tokens, it becomes difficult, especially when there are many different layers of annotation. In the case of PREMOVE, the original resource had around 20 layers, which means that even very low amounts of tokens had to take into account a lot of manual work, because a single token had the necessity to evaluate and implement 20 different annotations. And automatic pipelines based on natural language processing, NLP, can process text at scale, and it is fundamental that they are trained on high quality data, which has to be manually generated, and that is absolutely important. At the same time, if a tool is efficient enough and reliable enough, then theoretically it could be used to generate large amounts of data across a very short time, and the time that is saved can then be used to evaluate this data, which can then be linked online and shared openly and then reused by the research community, and thus creating new open data materials which might bring something useful to the entire research community around a specific field. And this is the main idea, that by using an LLM or simply an algorithm, natural language processing tool, we trade a bit of reliability to have a lot more scalability and gain a lot more data at scale. But this is a process that is hard to balance, and so this must be done very carefully, because the risk is having then a lot of data that cannot be used reliably, or worse, that leads to unfair conclusions because it has been annotated badly or not following specific guidelines, and that is something that must be absolutely avoided. In going more into detail, in natural language processing, the task of identifying the correct meaning of an ambiguous word, of a polysemous word, is called word sense disambiguation, or WSD. And there have been many promising traditional approaches in the last few years based on embeddings, based on BERT, which is an encoder-decoder model that is similar to large language models. It's based on the same transformers architecture, but it is a lot smaller. And very promising results have been obtained across different languages, including Latin and Ancient Greek. And so it has been possible to trace across even very large, very vast and different corpora the semantic evolution, the quantitative analysis of specific words, specific lemmas, and concepts, because this is a task that is inherently focused on semantics, so on the meanings of words rather than their form or their logical arrangement, their syntax. And this is also what we mainly focused on for the PREMOVE expansion, since many other NLP approaches apply to ancient languages that instead focus on morphology or syntax are a lot more reliable and already structured. Dependency parsing or name entity recognition or part-of-speech tagging have also been extensively discussed, and there are many tools already. But the semantic meaning is something that still needs refinements and improvements as far as tools go. LLMs in this context, as a very recent development, can be incredibly useful. They are massive models with billions of parameters, which means that they have a general knowledge of the world and of many different languages. And they can be instruction tuned, improved with a series of techniques, which I will delve into in a few slides. Some of these are prompt engineering, so using specific instructions, specific prompts to have LLMs reason in specific kinds of ways, but also in context learning, which is giving new pieces of information in the form of examples to a model during inference. So when a query is asked, so that the LLM is able to integrate this additional knowledge into its knowledge base. And even chain of thought, which is now employed by basically all modern state-of-the-art LLMs, which is a process which forces the LLM to reason on a query before giving a response to the user. But also fine-tuning, which is a technique which continues the training of the LLM by adding new data on a specific task. So creating a new LLM that is more specialized in a very specific subtask. And also retrieval augmented generation, which links an LLM to an external database, usually a vector database created with embeddings, and uses then retrieval algorithms to enhance the output quality of a response by grounding that same response in the documents which were retrieved. And the hypothesis is, can LLMs assist expert annotators in low resource settings? So when it is not possible to manually annotate dataset, could be because it is very, very large, or because there are time constraints, or cost constraints, budget constraints. Can this be done reliably with efficient results? And here I have once again another very brief question. You can once again scan the QR code, or simply go back to the tab which you had open before, or use the code. And I'll just switch to where I was. Yeah. I wanted to know, how proficient are you with linguistic annotation using LLMs in research contexts and or coding and programming in any language? And this will be very useful in the next part of the talk, where I will actually show the training resource, and I will try to perform automatic semantic annotation with LLMs. And knowing this, no, okay. So we have, okay, most of the people are pretty proficient with linguistic annotation. Most of them use LLMs in research contexts, and there's also some proficiency in coding and programming. Okay, and that was kind of expected, considering that it is a computational humanities seminar, but it is nice to know. Okay, so going a bit more in deep to the actual research, one of the first task that we tried with LLMs, apart from the usual manual annotation, is a Preverb semantics task. So are LLMs capable of identifying the specific meaning of a Latin or ancient Greek preverb in context? And how can they do so? They can do so by choosing an English translation between a list that was predefined already by Andrea Farina during his PREMOVE project. So this means that, for example, given the Latin verb circumvenio, for example, which means to go or come around, the LLM, seeing the word circum as a preverb, had to correctly assign the English meaning of around to that same preverb from a list of around 52 possibilities, which were predefined. And first, a ground truth was built by following the annotation guidelines of the PREMOVE project, and the inter-annotator agreement was computed between two researchers to ensure that the ground truth was clear and followed the guidelines. The model selection was not easy, because a balance needed to be found between the size of the model, which usually leads to better performances, openness, because obviously open models are more reproducible and in general should be preferred in academic research contexts, and performance, obviously, and also cost, since inference for large LLMs can sometimes be kind of costly. And this builds on another research study, which will be presented in a couple of months, when we evaluated 13 different model families on the exact same task on preverb semantics, focusing on verbs of motion. And we basically found that very large models perform better, that models which employ chain of thought were the best ones, even more than bigger models without chain of thought. And we also found that leveraging few shot prompting and so giving examples to a model was something that helped increase performance, improve performance, obviously without giving too many examples and confusing the model. And we had to find efficient prompts, and I will show in one of the next slides the final prompt which we ended up with. And we also had to play around with many different settings, including, for example, temperature, which is the setting which controls how much a model, how a model's outputs are predefined or casual. So a lower temperature is useful in contexts such as this, where reproducibility and research are the main targets. But for example, a higher temperature value can be useful in creating writing. And then obviously we had to perform evaluation. And we did this across two different approaches because we computed standard metrics such as precision, recall, and F1 score. But also we also inspected the data manually. And as a third addition, we also asked the LLM to output a confidence score, which is something I will briefly talk a bit more in detail about. And once the data is approved and verified, it just has to be shared and archived in some way. But let's focus and analyze all of these specific elements. Actually, we'll first introduce the second task, which is a lot more complicated to face, which is verb semantics. And while in the previous task, an LLM was simply asked to choose the correct meaning of the preverb, so of the small prefix which comes before a verb, and has a set of predetermined possible English translations. In this case, we wanted the LLM to actually identify the meaning of an entire verb. So to classify the specific sense meaning that a verb had in a sentence in a precise context. And this proved to be a lot more difficult because different verbs can have many different meanings. And the main problem is how can we give the model accurate candidate labels? So tagging meaning can be very complicated because there's not really a standardized way of classifying meaning. I mean, there are. One of these is WordNet, which is a very large electronic lexical database that can be used to group words into different sets of cognitive synonyms, which are called synsets. So, for example, if there are 3 different possible meanings for the verb look, in WordNet, searching for look gives these 3 different synsets, which are meanings assigned to look and to other synonyms, which have the same specific meaning. And this gives more options than vocabularies, which can be pretty faulty sometimes. And it is a standardized protocol that has stable identifiers even across different languages. So that means that a Latin word and an English word can be tagged with the same synset, since it is linked both to Latin words and to English words, for example. One of the problems is that it is very granular. So it has been found that even human annotators sometimes have difficulty finding satisfying agreement score when tagging WordNet synsets because they are very specific. and sometimes these differences cannot be comprehended efficiently. So there are many solutions have been tried to actually find relevant scene sets for a semantic annotation task. And some of these are, for example, embedding the definitions, the glosses of different scene sets, and then clustering them and retrieving the most relevant ones based on a user-specific query, or leveraging the hierarchy of WordNet, since all scene sets are organized in a vertical structure. It is possible to find the more general and the more specific scene sets of specific concepts. And another approach, which is actually what I ended up using in this specific context, is using a predefined set of lemmas and or specific scene sets for specific lemmas. And there is also the possibility of using specific WordNets for ancient languages. There is Latin WordNet and there is an ancient Greek WordNet. The problem is that they are not completely thoroughly annotated. So some meanings are missing, and it is not even really possible to know which ones are actually missing without inspecting them. So it is not a 100% reliable method. But these are all processes and problems that are being talked about and faced in various different research contexts at the moment. So I hope that in the future we'll have some more definite answers. Anyway, here I have just a very brief example of an annotation task with WordNet, which you can try, just to let you see the difference between a very simple scene set annotation task and one which I believe is a lot more complex. So here you can see how a sentence such as these, I believe, is very, very easy to annotate. What meaning we assign to the word see in the sentence, can you see the bird in that tree? Perceived by sight or date regularly, have a steady relationship with. And these are both true of the many scene sets which WordNet assigns to the word see. And in this case, I'll just show the answers. Yeah. It was incredibly easy. It means to perceive by sight. But in another case, this can be more difficult. Here we have once again the word see, and we have the sentence, you'll see a lot of cheating in this school. And this is one of the examples which WordNet specifically uses for one of these four scene sets. One of them is perceived by sight. Then we have perceive an idea or situation mentally. Then perceive or be contemporaneous with, and get to know or become aware of, usually accidentally. And as I was saying, you'll see a lot of cheating in this school is actually one of the examples provided by WordNet themselves to explain the meaning of one of these four scene sets, which are very similar. Okay, some responses are arriving. Let's see. Okay, well, we have different ideas, and okay, I'll just say the correct answer. The correct answer was actually perceive or be contemporaneous with, as the example WordNet gives for perceive or be contemporaneous with is you'll see a lot of cheating in this school. And as I was saying, that isn't very clear or immediate to understand at all. So that is a problem of working with very specific scene sets. And an LLM obviously has trouble identifying these differences too. So moving on. I'll just move on to talking about some of the specific approaches that we used and we found to be efficient to improve the performance of an LLM for a semantic annotation task. And the first one, and maybe the most obvious one, is efficient system prompting. A system prompt is different from a user prompt, as in a system prompt controls what the LLMs knows are its general instructions for across all different queries, as if they were their identity and their role, while a user prompt gives a very specific question. So if in a system prompt of an LLM, there is an instruction such as be very kind and gentle and explain everything clearly, then a user prompt which simply asks for what time is it will have a very gentle and kind explanation, for example. And a system prompt has to be detailed and clear, but at the same time should not be too long, because LLMs have a limited context window of tokens they can process before getting confused and starting to forget and hallucinate. So a balance has to be found between being very specific and being too descriptive. And it can be useful to format the prompt in Markdown, which is a language to format your text, as you can see, with headers and lists. And in our case, this was the system prompt which we used for the Preverb semantic task. So a first section of the prompt stated the role and goal of the LLM. You're an expert in ancient Greek Latin linguistics. You will be given an ancient Greek or Latin sentence that includes a preverb motion verb, or in our case, perception verbs. Your primary task is to identify the semantics of the preverb, considering the compositionality of the verb. Then we have specific guidelines in a list. The semantics of the preverb must be annotated depending on the specific meaning that the preverb acquires in context. If a preverb does not possess a clear lexical meaning and only contributes to italicizing the verbal base, tag it with completely. I won't go on into the linguistic details of this, but I think it should be pretty clear anyway. In some occurrences, two meanings may overlap, annotate both. And this was actually very useful. Because in our original resource, some preverbs had more than a meaning tagged. So we had to give this example and this possibility. But at the same time, it was useful because it helped us understand which kinds of errors the model did, and if they chose the wrong preverb, maybe they chose the correct one as a second guess. And so that was something that could be used to understand where the errors were clustering around. And then output requirements, which is incredibly important because LLMs, especially smaller ones, tend to have difficulties outputting text in a specific format. And if we then have to evaluate their output, it has to be very standardized. So we have to ask them to simply output what we are asking, and so a simple meaning and nothing else. Otherwise, it is impossible to efficiently evaluate what they are saying. So we wrote to respond with only one or two English meanings from the list provided below, and this can be adverbs, propositions, or multiple expressions. Provided nothing else, no explanations, no conversational text, and no punctuation beyond what is in the expression itself. If you need to annotate two meanings, separate them with a comma followed by a white space. And so we avoided models asking something like, responding with something like, certainly here is your annotated preverb, and then saying the preverb. And then a list of allowed meanings, and these were 52 meanings in alphabetical order. So I simply included the first 3. And this was a prompt that actually worked pretty well. For the verb semantics task, we tried a different kind of prompt, which was shorter and more structured, maybe. And we simply instructed the LLM saying, you're an expert in historical linguistics, Latin, ancient Greek, and lexical semantics. Your task is to select the most appropriate word in its scene set that best captures the meaning of Latin or ancient Greek verb in context. You will be given a verb token in its original form, the lemma or the dictionary form of the verb, the sentence context, and a numbered list of possible synsets with their definitions, and some annotated examples for reference. Analyze the context carefully and choose the synset that best matches the semantic meaning of the verb. And then important, respond with only a single number corresponding to your choice, because previously in the script we had a function that assigned a stable number to a synset so that they could avoid rewriting the actual code, which is pretty long. It could be confusing. And do not include any explanation or additional text. And all of these can seem obvious, but we also found, as I was saying, smaller models which had trouble following these output requirements. So even just changing a few words and being a bit ambiguous in some places can lead to catastrophic failures. And another thing that can be added to system prompts, and we tried it in a few runs, is asking the model to output apart from the prediction a confidence score for its prediction between 0 and 1. So ideally, if an LLM is absolutely sure of its results, it should output something close to 1, otherwise something closer to 0. And what we found in some tests is that LLMs tend to give high scores across all different cases and runs, but that relatively lower confidence scores are correlated with wrong answers. So even if an LLM gives a confidence score around 0.8, that means that maybe a human should check it, while higher confidence scores usually are more reliable. And then we focused on in-context learning and few-shot prompting, because giving examples can help a model distinguish between edge cases and understand the specific requirements. Too many examples, just like a system prompt that is too long, can exhaust the model's context window, and the middle ground has to be found. And obviously the ground truth has to be reliable, because if we have incorrect examples, then the model will almost always be misdirected and give a confused or inappropriate answer. And we found that 5 was usually a good number for examples. And obviously they should be examples as close as possible to the actual thing that is being annotated. So possibly the same lemma or the same preverb in our case. Model selection and settings, and that's pretty important too. For ancient languages, for classical languages, there is a shortage of accurate benchmarks, because even models that should outperform other families can be worse than those same families on Latin or ancient Greek, based simply on the number of tokens and texts in Latin and ancient Greek that they have been trained on. And that isn't really something that is documented. So, for example, in our first tries, we focused on European LLMs under the assumption that maybe they would have more Latin or ancient Greek in the training data. But then we found, for example, that even Chinese models perform very similarly. And high parameter counts usually lead to better results, but small models can be more affordable, obviously, open and privacy focused. In our case, it isn't really a problem, because since all the data we're analyzing is centuries old, there is no privacy problem. And they can be also fine-tuned. As always, being clear, simple, and straightforward helps. Temperature should be lowered, as I was saying, and chain of thought is another element that can enhance the performance. Then obviously there is the verification. I already talked about confidence score, precision, recall, and F1 are standard metrics, but then a close reading of the automatic annotations which were created is always a good idea, because it can also lead to discovering specific faults in the setup that had been overlooked at the start. Fine-tuning is, I believe, one of the most interesting possibilities, because it is a process of continuing the training of a pre-trained AI model on a specific smaller data set and specialized abilities. Specifically, low-rank adaptation is a technique that is being used a lot because it is pretty affordable and fast. There are a lot of tutorials and libraries to do that, and it trains small specialized adapter modules instead of the entire model, which is very large. And we found, for example, even very, very small models basically doubling their performance on Preverbs Semantic, for example, once they were fine-tuned for a fraction of the cost. And this leads me to the very last part of the talk, which is the design of an interactive tool for LLM-based annotation. Because I asked myself, can it be possible to create resource for humanists or people who work in linguistics or classics who may need to perform semantic annotation at scale of very large text, but do not have the computer science expertise that is necessary to use LLMs and APIs at scale? And so I tried to develop a notebook that is based on Google Colab, which is a platform that lets users execute Python code with high-end computing resources given by Google without having to look and use code specifically. And the idea is crafting a very simple and accessible interface that can be then remastered, remixed, and reused however one likes. And so I will show this notebook, and if someone wants to actually use it and follow along with the steps, they can do that. Otherwise, they can simply follow what I do on the screen. And here's the link and the QR code to access the notebook. And now I will just give a couple of seconds to open this link, and then I will open the notebook too. Okay. So, just a moment. Okay. This is Google Colab, and as you can see, no code can be seen, but it is all underneath this layer. And there are a series of specific instructions on what semantic annotation is, what the notebook is about, and how it should be used. But I'll mostly explain these instead of reading along. And the first thing to do, since this is my copy of the notebook, is to save a copy on your specific Google Drive. You can open File here. Sorry, it is in Italian. And save a copy on your drive. This is roughly the position, and I can do that just in case. And then it opens another window with your saved notebook, and this is exactly the same as mine. There is a copy at the top, but it is yours, only accessible by you, and you can use and modify it. The first thing to do before starting is connecting to a runtime. Okay, is connecting to a runtime like this, and this lets you use Google's resources. And then what you need to do is simply run the cells one by one by simply clicking the small arrows here. So for example, this will install the necessary libraries and download the WordNet database. And it will take just a couple of moments. Then there is the API configuration, and it is the API is a specific key that you need to use use specific LLMs. So in our case, we will use, for example, DeepSeek, and creating an API key is very, very simple. You can simply go to their site, their platform, and you have here API keys, create new key. Simply name it test, and then copy it. You can see, because then I will destroy it after this talk. And once there is a green check mark, we can go and continue. enter our API key by simply pasting it. Yeah. Then we can define some specific settings. We will choose simply the main DeepSeek model, but we can choose any model we like, even from OpenAI or OpenRouter. Specify a reasoning effort and the temperature. These are all standard values that I have chosen. Then there is a system prompt. This will apply it, and this was the one I initially chose, but then it can be modified by simply writing and modifying our prompt. To give an input to the model, I implemented the option to simply write as a text input or upload the CSV or a JSON file. In our case, we will upload the CSV, which has a specific format which is specified in the notebook. And to do so, we simply need to upload a CSV here. This gives us the possibility of choosing a file, and then I will simply choose our example file here, and this has been loaded. Then this will get our candidate synsets. Here you can see, for example, the verbs that I gave. And then the annotation can be run here. Okay. And once we do everything, the annotation can actually start. And here you can see it is doing the first one, which is correct. Then the second one has been predicted incorrectly, the third one too, and the fourth one too. I actually used a very fast model just to give you an idea. We can see the evaluation of the detailed results, what is correct and what is incorrect, and the evaluation metrics. Here it was very simple, just for example. So one was correct, accuracy of 25%. And you can export the results in a CSV file, for example, and open it to see the actual results which were annotated. So I think we are almost out of time. So the notebook is obviously open, and I just explained it very, very briefly, but feel free to look at it since there are very detailed instructions inside if you're interested. And I'll actually end the talk with a final question on this resource. If you believe it could be, it could have some new functionalities or some new implementations, you actually can leave some feedback on what you would like to see, or if it would be useful for you to have something similar in your research process. So one of the questions, for example, is which of these topics would you like to learn more about in a context such as this: data preparation, prompting, setup and settings, evaluation from 0 to 5. Data preparation as in having your data be in the right formats for an annotation. Prompting, it should be pretty self-explanatory. The setup and settings that a specific model needs, and how to evaluate the output. And then apart from this, there is also another question asking if you think that you could use something like this, a notebook such as this alone, if you think you could use something such as this in your work, if it is relevant to the field. If you're not a digital humanist or linguist, maybe you won't need it. And if the instructions were clear and easy to follow, in this specific case, mine, or ones written in the notebook. And any other suggestions or improvements in Preform can be written here. So I will. This will remain active for some time in case you want to look at the model in the notebook more calmly and take a look. But in any way, any feedback can be given even just by writing me an email, since here are the references of the talk and my contacts for anything, and the actual data of the notebook, and not only that, but also the sample annotations, templates, and so on are on GitHub at the QR code here. So that is all.